but now I get scared. Okay,
Okay,
all
why
right.
don't you print all the charges? Let's start there. So again, this is actually how I program, right? Like it's not all. You don't just like sit down and write the whole thing. Like I do this debugging myself.
Okay, that makes sense. Yeah.
Um, uh, I say, hey, what does this field look like? What does the first element look like? What does the field on the first element look like?
Right.
Um, yeah. So sorry, printing all of them means I was trying to imply that we should go ahead and fire up a loop.
Oh.
Yeah, you can't just print all of them at once.
Well, now I feel stupid.
No, that's a good guess. I mean, some languages let you do that.
Okay. Okay, so I'm gonna do this. Okay, so for I in hi. What doing? Huh? Yeah, you can come in. What? Okay. All right. So am I at least off to a good start right here?
Yep.
Okay.
Yep, that is how you start a for loop.
Do I also so do I need to borrow these values again?
Yes.
Okay.
Very nice.
Well, what can I say? Oh wait, I need to do this. Dot charge. Wait, hold on. How do for loops work again? Oh, I see.
What are
Yeah.
you trying to loop over? Yeah, yeah.
Well, I want to print all the charges.
Okay. So remember when you do the index, you're indexing a single atom.
Oh, right. So I would do that instead.
I'm waiting on Jitsi. No, remember you can't access all the charges at once. Although I told you that was a good guess. That would be nice if you could do.
Yeah.
Look at what it's telling you. What is the type of I?
I is an atom.
Yeah. And so you can now access I's charge.
Oh, like this?
No.
Oh.
Okay, maybe you do need to look at how for loops work.
Okay, sweet.
Remember, yeah, so for line in contents.lines.
Uh-huh.
We then used line inside of the loop.
Yeah.
So maybe you want to rename I to atom, since it has type atom. Because that'll just make everything sound a little better.
Okay. Okay, so for atom in... Okay.
So tell me what you want to do again, just in words.
Oh, I just want to loop over the charges of the atoms.
Well, let me tell you what I want to do.
Okay.
I want to print. I want you. Let me tell you what I want you to do.
Okay.
I want you to print each atom's charge.
Okay.
So phrased that way, what you've written so far is for each atom in atoms. This is why in Perl you can actually write for each instead of just for.
I see.
For each atom in atoms. What did I want you to do?
Print the charge of the atom.
Yeah.
Okay. So is this done right here?
Yeah, you need some curly braces and then you need to actually do something.
Okay.
So that is, yeah, you're done with the actual for loop syntax.
Okay.
Yeah.
Yeah. Hold on. I can't just type charge, obviously, right? I need something else.
Yeah. So what is charge?
What do you mean, what is charge?
In Rust terms. What is charge's relationship to atom?
Charge is a vector in atom, right? No? Okay.
No, remember the atom holds a single charge. Remember we've got our template. I told you to leave the template.
Yeah, I didn't know that's where I needed to start accessing that information.
Yeah, if you want to print each atom's charge, you just print atom.charge.
Okay. All right. Is it just atom dot charge, or do I need that whole? This whole thing again?
No, just atom.charge.
Okay.
So yeah, what we were doing in the template is we had molecule, right?
Yeah.
At first we debugged the whole molecule. Then we debugged molecule.atoms. So we accessed the atoms field on molecule. And we saw what that looked like. Then we added the brackets to only print the first atom.
I see.
And then we added .charge to print the first atom's charge.
Yeah.
Okay, so what you did with the for loop is for atom in atoms, you essentially access, inside of the for loop, you're accessing each one of the atoms in turn.
Okay.
So that's just, the for loop is basically just like if you had run mol.atoms of 0, mol.atoms of 1, mol.atoms of 2, and so on.
Atom is taking the place of this index here?
Yes.
Okay.
And so then you call the whole thing you have there, ref mol.atoms braces, you've called that atom. So you've assigned each one in the loop to that, and then you just call atom.charge.
Okay.
So that should work.
Oh, wait. The error originates in the macro dbg.
Yeah, so the important part of this one again is expected unit found U size.
Okay.
And that's just because you don't have a semicolon again.
Oh, okay.
So it basically thinks that you're returning the last charge from the function.
Okay.
If you don't have the semicolon.
I see.
And there you go. You can see all the charges.
Okay. Okay. I think, okay, so if I wanted to take this idea and start actually accessing the X, Y, and Z components.
Yeah.
Okay, I think my next question is, how would I? Oh, okay. Wait. Would I need to have like okay, just 4 atom I and then a 4 atom J, or is that thinking too hard?
Yeah, that sounds reasonable.
Okay. Okay. So like on this, if I were to just take what I have right now,
yeah.
If I wanted to say 4 atom, and then if I put an I here, and then I do the same thing, but I say 4 atom J in, let me borrow this real fast, mol dot atoms.
Yep.
Okay. So now I've accessed atom I and atom J, and now I want the X component of atom I and atom J.
Yep.
So if I just print real quick, if I wanted to print atom I dot X, can I do a comma and print the other one? J dot X.
Perfect.
And now I've already closed this one here and here. Okay. Oh yeah, forgot. Right? Or okay. Oh, I see. I'm just gonna get rid of this. I don't want it right now.
Nice.
What is that here?
Oh, that's actually the old error still.
Okay.
There you go. Looking good.
Feeling pretty good. Okay. All right. I'm understanding that now.
Good.
I guess now I need to do some math, huh?
Now it's just math.
Now it's just math. Okay. All right. So How do we do math in Rust?
I
Like,
think it's probably how you would expect. I hope.
I think I speak for everyone, including all of YouTube, when I say that I doubt what I'm expecting is what you're hoping that I'm expecting.
Well, the first step is how you would expect. So let's go back to the distance formula.
Yeah. So I just want to do this part right here, right?
Yeah.
Okay.
So the power is definitely not what you might expect, but
Yeah.
the subtraction is the usual way.
Okay.
As I might say.
Well, would I want to save? This is probably more than it needs to be as well. But so if I want to do like the way that I'm thinking about this in my head is to do it piecewise.
Yeah.
So
that's
like
fine.
so X's, I guess,
Okay.
would it be let mute or just let? It would be let mute because we want to do something with it later, right?
So again, I always default to not mute.
Until it tells me to mute.
If I end up needing to mutate it, I'll add mute later.
Let X's equal the subtraction of atom I dot X. I can just do minus like that and it'll work.
Yep. Yeah.
Atom J dot X.
Just like a calculator for the arithmetic parts.
Perfect. All right, so the X's are doing this thing.
Yep.
Okay. So now I also want to square it.
Yes.
Okay, so how do I
the easiest way to square it is probably to put those in parentheses.
Okay, just like a calculator.
Yeah, okay, yeah, like calculator.
Okay.
And then, so just like other types, remember like vector, we did like vector push. What else have we done? That's mainly we've done parse on strings, right? Methods.
Dot squirt.
Floats also have methods. Yeah, it does actually have a square root.
Oh, but we want to square it.
We don't want the square root. Yeah.
Sorry, that was my brain stupiding.
So the function you'll want to call is powy.
No.
It's pow-I.
Okay, powy, and then would I just do 2?
Yeah.
Okay. Okay, cool. That's kind of neat.
Yeah.
Nice. Man, that's so cool. And now I can do the same thing, but for Y and Z, right?
Yep.
Well, these
Y
are the...
and Z, of course.
Yeah, Z, of course, yes. R, Y, R, Z, and then I'll do the same thing over here. R, Y, R, Z.
Perfect.
Okay, nice. Now I want to put it all together.
Yep.
So now I need to do... I gotta remember how to do this. Oh yeah, okay, so... Let BL, I don't know if this is what you would do, but this is what I would do, equal X's plus Y's plus Z's, and then is there the dot squirt?
Yep.
Oh yeah.
You typed it so fast the company got scared, but yes, it is there.
Okay, perfect. Whoa. Dude,
that is not the right formatting, but it will work.
Oh no.
Now that's actually what they do in OCaml.
Oh, BL. It says is that already something? Unused.
It's unused. So let's debug it just to get rid of that warning. Let's see it. Yeah.
Oh, you mean run it? Run the code?
No. Like if you say you're not using BL, you're just assigning to it. That's what the warning is about.
Yeah.
So if you dbg BL, that will get rid of the warning because you're using it by debugging it.
Oh, you mean like under this line?
Yeah.
Okay. I see. So dbg.
Yep.
BL.
Borderlands.
Yeah, good one. BK. Chunky's dead. All right. I'm feeling that second.
All right, it's mad about your semicolon again.
Yeah, dang it, dude. All right, perfect.
There you go. You're computing all the bond links.
This is so cool.
So I guess we can go take a look at the Crawford project if you want and check your answers.
Yeah.
So they're not going to be in the right. They're not going to be in the right order or anything, but
yeah.
At least we can see if some of the numbers look the same.
Solution. All right. Well, 2.84511. Hey, look.
There you go.
All right, that's good enough for me.
Yeah, one and done. That's
one and
it.
done. You know, one at a time.
We spot checked it, so they're probably all right.
Yeah. Yeah, they're okay. Nice.
All right, cool.
And this is the rest of the project.
Yeah, pretty much.
Some variation of this over and over again.
Yes. Yeah.
Man, I was all right. After this, I felt like I was flying.
Good.
But I mean, you know, nice. Okay. Wait, do I want to? I don't. Yeah, I would want to save the bond links as something.
Yeah.
Or I'd want to return the bond links, I guess.
Yeah, so there are a couple things to do here.
Yeah.
Possibly. Yeah, so returning them is one thing we could do.
Yeah.
Another thing we could do is try to mimic their printing style, you know, where they show the atom index and then the bond length.
Sure. Yeah.
Yeah, it's up to you. I mean, this is good. Like, yeah, I hope you felt pretty good about this. So
yeah,
that's how you loop over a vector right there. Oftentimes you want to borrow it so you don't move the vector away. And then you access the vector by doing dot atoms on mul.
Okay.
Yeah, but that looks good.
Nice.
I think the index thing might be useful. I think we should probably do both of them if you want.
Yeah, I mean, yeah, that's fine. Yeah, we can do that.
Okay. So, all right. This time we'll be we'll be stricter. We'll be more careful with our refactor.
Okay.
Okay. So this looks good, right?
Yeah.
So, this is some syntax sugar, this for loop.
Okay.
Okay?
Okay.
I think I mentioned this last time, but for loops have this magical interaction with what are called iterators.
Okay.
So when you do a for loop, it actually calls a method on whatever you're looping over.
Okay.
So this is actually equivalent to for atom I in mul.atoms.iter.
Yeah, okay.
So you call the vec iter method, and that returns an iterator over the vector.
Okay.
Which the for loop can use. So Rust does that automatically for you. You don't have to write .iter. If we want to get the indices, we actually are going to want to call iter ourselves. So without changing any functionality yet, just call iter yourself. So let's do mul.atoms.iter. And you'll see why we're doing this when we do the second stage of the refactor.
Okay.
Yeah, you'll see now you get an awful function signature, or I guess type signature. Oh, we might have to remove the borrow.
Okay. No, wait. I want it to tell me.
Sounds good.
Consider removing the leading. Okay, there we go. Perfect. Consider not borrowing it and just taking it.
Yeah. So the other magic trick that it's doing with the for loop is a for loop. So this, okay. Hopefully, everybody who is about to make a comment about for loops calling iter will see this part. For loops actually call into iter for you.
Okay.
But when you call into iter, it moves the thing, like it consumes the vector and it becomes an iterator. It really does transform into an iterator.
Okay.
If you want to leave the thing behind, you call .iter, which for loops also do magically for you if you borrow the thing you're looping over. Okay. It calls. I don't know if it calls into iter on the borrowed thing or if it just knows to call iter instead. Something like that. It doesn't move it. But if you call iter yourself and then you try to borrow it, then it tells you, oh, this borrowed iterator is not an iterator. Only the iterator itself is an iterator.
Yeah.
So that's why you had to do that. Okay, so now if you run it,